Hello everybody, let's continue our discussion of concurrency theorems for triangles in Euclidean geometry. Okay, we have the second theorem here. We have the second theorem which says the medians of a triangle are concurrent. Medians of a triangle are concurrent. So let's first understand what median means. Okay, so if we have a triangle PQR, let's say, and let's say S is the midpoint of QR, then the line joining P and S, this line is said to be a median of the triangle. Median of triangle PQR drawn from P. Okay. Similarly, if T is the midpoint of PR, then QT is the median of the triangle PQR drawn from Q. Similarly, if U is the midpoint of the side PQ, then RU is the median of triangle PQR drawn from R. Okay. All right. Now to prove this theorem, consider a triangle PQR. Okay. PQR. Let's say T is the midpoint of R. Okay. T is the midpoint of R. U is the midpoint of PQ. T is the midpoint of PR. U is the midpoint of PQ. Okay. So we have a median drawn from R, a median drawn from Q. Okay. Now, for the sake of contradiction, for the purpose of contradiction, we shall suppose that now if the median drawn from P passes through G, we have the proof at hand. Okay, it's already proved if it's like this. So we shall suppose that these two lines intersect at G. Okay. Now, for the sake of contradiction, we shall suppose that the median drawn from P does not pass through G, then the medians are not concurrent. Okay, so for the sake of contradiction, for the purpose of contradiction, let the median drawn from P not pass through G. Okay, let it not pass through G. Now let's just join PG and extend it indefinitely. Okay, let's join PG like this. This is PG, and extend it indefinitely. Okay, this point is G, or should I write it over here? This point is G. Now, what we do is we draw a what you call. Okay, let's suppose this angle is alpha. Okay, let's suppose this angle is alpha. Then we construct angle RQP dash such that RQP dash such that P dash is on PG. Okay, is on the line PG. Let's call this point S. All right. On P, sorry, the point P dash is on the line PG or PS, whatever you want to call it, such that angle RQP dash, this angle is alpha, like this. Okay. Then what is happening? What is happening? These two lines, okay, RGGR and QP dash, something like this, and this is alpha, this is alpha. Since the alternate angles are equal, these two lines are parallel. Okay, so this is parallel to the entire line, what you call RU. So just in case you don't get confused, so we have this, okay, this parallelism. Now let's focus on triangle. Let's focus on triangle PQP dash. PQP dash. Then let's see. U is the midpoint of PQ, and UG is parallel to PQ dash. So what we have is PQP dash. U is the midpoint, okay, U is the midpoint, and something like this. This point is G. Okay, this point is G. So by midpoint theorem, since U is the midpoint and UG is parallel to GP dash, sorry, UG is parallel to QP dash, G is the midpoint of what you call G is the midpoint of P dash. So this part is equal to this part. Okay, this is equal to this. PG is equal to P dash G. PG is equal to P dash G. Now what we do is we join P dash with R. We join P dash with R like this. P dash with R. Why? Okay, no problem. P dash with R. Now let's see. T and G are midpoints of P, R and PP dash respectively. So now consider triangle PP dash R. PP dash what do you call R? Midpoint, G is the midpoint, and T is the midpoint. T is the midpoint. We have GT, align GT like this. Then again from the midpoint theorem, the line joining the midpoints should be parallel to the third side. Okay, so we have QT to be parallel to PRP dash. Okay, that's all. Now let's see. Here's point S. Okay, here's point S. Now let's see. QG is parallel to P dash R. Opposite sides are parallel. Again, GR is parallel to QP dash. So again, opposite sides are parallel. So GQP dash R. G, Q, P dash R is a parallelogram. Parallelogram. Okay. G, Q, P dash R is a parallelogram. We know that the diagonals of a parallelogram bisect each other. So this is equal to this, and this is equal to this, isn't it? So S, hence S is the midpoint of QR and P dash G. QR and P dash G. Okay. Now we've assumed that the median drawn from P does not pass through G. So let's consider this to be the median from P, median drawn from P. Then by definition, if this point is M, then this point M should be the midpoint of QR, isn't it? The point M should be the midpoint of QR, as a result of which we have two midpoints of the side QR, which is a contradiction because a line segment can have only one midpoint. Okay, exactly one midpoint. So this assumption leads us to a contradiction, which means this assumption is false, as a result of which the median drawn from P passes through G. Okay, the median drawn from P passes through G. So this is the median, this is the required median, and this will be the midpoint. This will be nothing. Okay, this will not be a thing. So this is a median. So our theorem is proved. But wait, we've got a little more of deduction to do. Not only that medians are concurrent, there's another interesting property. By the way, this point G, the point of concurrency, okay, the point where all three medians intersect, this point G, this point is called the centroid. Okay, the point G is called the centroid. Centroid of a triangle means point where all three medians meet. Okay. Look at my handwriting. All right. Now, let's see. We've already shown that G is the midpoint of P dash. So PG is equal to P dash G. Again, S is the midpoint of P dash G. So P dash G is twice of GS, 2 times GS, which shows that if P is a vertex and P is a vertex of the given triangle, and S is the midpoint of the opposite side, then the median PS is divided into two parts by the point G, such that this is twice of this. So PG is to GS is in the ratio 2:1. So the median divides, sorry, the centroid divides the median in the ratio 2:1. This is what we are supposed to deduce. This is a very important result. Okay. Oh my God. All right. That's about it. And yeah, if this Q, I'm taking an acute angle triangle. If this point Q is right angled or obtuse angled, the same construction will work. Okay, the same construction, same notations will work. And in order to deduce that QG and QG is to QGT is also 2:1, and RG is to GU is also 2:1. Simply we are taking QR as a base, right? We were taking QR as a base. In your deduction, just take, once again, you're supposed to take PR as a base and then PQ as a base. So 2:1, 2:1, 2:1 will follow immediately. I'll leave that for as an exercise, and I'll also leave the cases where Q is obtuse angled and Q is right angled as an exercise. It's just exactly the same process you've seen just now. All right. Okay. Thank you very much.